Hello friends, today I will explain you how to design an CMOS based voltage controlled oscillator or ring oscillator. It is not exactly voltage controlled oscillator, it's a ring oscillator based on CMOS circuit in Cadence. Okay. So first of all I am creating a folder. So it's naming as ring oscillator. So next I'm using this library description file to load a 45 nanometer technology library. So you can see that library description, all the other basic library description and the path of GPDK 45 nanometer technology that is specified here, and here this is not necessary. Okay, this is not needed, so I am deleting this and saving. Again I am coming to our actually I created a folder wrongly, so I am deleting that. Opening a terminal and then opening Virtuoso, Cadence Virtuoso tool. So the tool has been opened, and now I'm going to library manager and creating a new library and giving Ring OSE project. Okay. And attaching an existing technology file. Okay, and GPDK. Okay. So here it will show that is like your technology files has been loaded like. Okay, and giving okay. So the library has been created. Now you have to create a cell view. So new file is ring oscillator and I'm giving ring OSC. Open with schematic. Yeah. Okay. Okay. Now I have to add the inverter. I have to create an inverter. That means I have to add the transistors. So here I am using this transistor. So keeping all default width and length, and it's an NMOS. I need on PMOS. Pressing escape and coming to here and selecting a PMOS and creating an inverter based on this. Similarly here for connecting wires like Synopsys Custom Designer, here also the keyboard shortcut is W. You can wire this and I need VDD and ground. So again here in analog library, so here it's available. You can type here VDD and escape, then VDC and GND. Okay, so now I have to connect this. Okay, and I need this VDD terminal. Just I am copying, that is nothing, just you press C and just copy. That means just click on the block or terminal or which you need the schematic, from the schematic. So this one should be connected in the so this is now a single inverter. Okay, so now you have to you have to serially connect this together. So again I'm copying this and making okay. Now for inverters, this output should be connected like this, right? So should be connected like this, and this should be connected in like this manner. Okay, everything fine. So the voltage you have to give like 1 volt. You can give. Then so here on capacitor should be connected. That is very important. Okay, so here I have to take a capacitor. So cap 1 picofarad defaultly. and ground. So again I need a ground, 3 grounds, sorry, 3 grounds I need. So here one, and here one, and here one. It should be connected, so you can just connect like this, so it will be connected. Okay, now this should be connected like this manner, so here and similarly here. Okay, so everything is fine now. Okay, so now you know this is the output terminal, so you can name this as out. Okay, so I'm checking for any errors. Okay, so no errors. So next I have to ready for simulation, so I'm going for ADE. Okay, so ADE, and okay, transient. So I think I can give for 10 micro, and I will check. Okay, play. Okay, outputs should be plotted from schematic. Then one more thing, initial value for output you have to set. So you come to simulation, convergence, initial condition. Okay, and so here you can select this. Okay, it should be added. So should be value, not voltage should be 0, should be set for 0. Yeah, so here you have to set the initial condition for this node or this particular wire. Okay, so for that you can go to simulation, convergence aid, and initial condition. Okay, so already I have set here, that is nothing. So it will be simply like this. Okay, then you can give here first 0, then you just choose the wire. Sorry, yeah, you choose the wire like this. So I can show you one more time. So you can go to simulation, convergence aid, initial condition. So just select this wire, so it will come like this. Then apply. Okay. Okay, now you can come to this window and you can give here this simulation time for 1 or 10. Okay, I think it will suit. So then you can run. So it will open Spectre. So in Cadence, sorry, in Synopsys Custom Designer, we are using height space. So here we are using Spectre. So same thing. Okay. So here you can see the output. So this is the oscillator output. Okay. So it will be more clear if you are giving or lesser timing. Okay. For example, like 5 or 2.5. It will be clear, more clear, the waveform. Okay. So you can run this. Yeah, so this is the Paka output which you are getting from Ring Oscillator. Okay, now this, if you want to, you can analyze this frequency of this output by varying different capacitor value. So that you can do by using parametric analysis. That is parametric, that any variable you can set and you can change. So that also I will show you here. So before that, I'm going to save this state. Okay, and here, so this capacitor value I will give as a variable. Okay, so here I'm giving like C underscore VAR. Okay, and I'm copying. So here also you can press Q. Sorry, I think it's not copied. It's okay, you can type here. Given C VAR variable. C underscore. So here also Q and C underscore VAR. Okay, that is, it was in picofarad. Okay, so here, and I'm coming to ADE, and here first I'm loading the previous state. Okay, so here I'm adding a variable. Okay, so it is available here like edit variable. So you can copy from diagram. Okay, so it automatically come here. You can give a value. So value initially how much, 1 pico. Generally you can give it's 1 pico. Apply and okay. So defaultly it will work for 1 pico. Okay, so now I have to change this. Okay, by using parametric analysis. So I'm coming to parametric, and here I have to add the variable. Okay, so here when you are double clicking, so defaultly temperature will be there, and this is the variable which we have added. Okay, and here its value, constant value 1, and this I'm varying from 1 pico, okay, to, just for testing I'm giving 10 pico or 100 pico, and total steps, so how many steps I need. So I'm just putting, I need 10 steps. Okay, 10. Okay, so now I can run this. Okay, just I'm going to run. So before that you should make sure that you have saved this. It's very important. Okay, and I'm going to run this. So here it will show the progress, and yeah, this is the output for different capacitor values, okay, for inverter. So that by the same way, I think already I have published one tutorial in that we have used Synopsys tools for analyzing the characteristics of DC characteristics of inverter. In that we have used I have used a tool that is custom LabView. So similarly here waveform analysis in Spectre, they are providing a tool. Okay, in this you can see I have swept here this value, capacitance value, so you are getting different output. So you can ungroup this. So for each capacitance values and their color is available. So this is for 1 pico, okay, and this is for 16, I think, yeah, 1.6, okay, and this is 100. Okay, so this you can see that how the capacitor, that means if the capacitance value is less, okay, so then you will get a higher frequency, so that you can see here. So just I'm ungrouping this, so you can go to graph and split the current strip. Not separating. Actually it has to split. I don't know what's happened. Oh, just a minute. So here you can see for different values of capacitor, you are getting different frequencies of output. Okay, so this is so mainly in this tutorial we have studied how to design a ring oscillator by using inverter in 45 nanometer technology, and as well as we have analyzed the timing diagram based on different capacitor values by using parametric analysis in Cadence Virtuoso by using spectral simulation tool. Thank you for watching.